Hello students. Uh, in this video lecture, we will discuss about the schemas. Uh, the terminologies used, what is a schemas and what kind of terminology used in the schema. So in data warehouse, look, schema is not only the part of database, it is also part of database. The logical description of the database are defined as a schema. When you design your structure to create your table or to create the relation between the tables, the structure will actually help to describe the relation between two or multiple tables is defined as schema. We can say it's type of a blueprint who define the references inside the databases. It also defines how the data are organized and how different number of tables and data are related to others. If we talk about the relational model, like a normal database and the data warehouse, different schemas are actually work with them. That like star schema, snowflake schema, fact constellation schema. So we have three type of a schema who actually work for data warehouse as well as database. In relational database or RDBMS, we generally apply the concept of snowflake schema, where a table define the references of the other. But if we talk about the data warehouse, schemas has three categories like star, snowflake, and fact constellation. But before discussing about the schemas category, we need to know about the terminology used in this process. Okay, so it consists two type of terminology. One is dimension and another one is measure. So dimension. Actually, dimension is nothing but a term which applicable in the data warehouse to collect the references of the information about the measurable event. I mean, if you want to connect two or multiple tables or two or multiple information together, you need to connect them with the help of references always. And dimension always identify that kind of references. We can also define the attributes of table. It's defined as the dimension. If you perform the numerical calculation with the attributes, is identified as a fact. The dimension are generally defined as an entity which actually hold the records, or we can say the attributes through which we can identify the records are defined as the dimension. If we define the dimension as an attribute, it's quite obvious to hold the primary key by these dimension always to identify the unique records. So basically, if we talk about the dimension, it holds the details related to the attributes of the table. For example, if we take the example of a student's dimension or attributes, it could consist the first name of a student, the last name of a student, the roll number of a student or the registration number of a student, the age, the gender, and the address. So these are some example of the dimension basically used for the table to identify the records. So here is another example of table. Here we have two tables, location dimension and item dimension, with different attributes like location ID, street name, city, state, country code, and item dimension has item code, item name, item type, brand name, and suppliers. So these are some dimension including the primary key and the different number of attributes. We can take another example of the student records similarly. Okay, if we define the dimension, we need to identify the unique records by the primary key, and the data should be present in the normalized format. But in data warehouse, data is always present in the denormalized table or may have the redundant data. But what is normalization here? So basically normalization as like the location dimension table. We have different number of attributes. But is this the normalized table? Well, normalization, what is normalization? Normalization is a process of breaking up the large table into the small. I mean, we have already defined the normalization in the database chapter. So normalization is nothing but split the data, split the larger table into the some different number of a smaller table, and apply the different number of manipulation like insertion, updation, and deletion to remove the anomalies. It just protects the data from the data redundancy also. Whereas if we talk about the denormalization, here different number of small tables are merged into a large table and reduce the joining operation. So data warehouse work with the denormalization format. Suppose if we take the example of the employee and department database, there will be two normalized table like employee consists the employee name, number, employee ID, I mean employee name, job, salary, department number. Whereas department consists the department number as an attribute, department name, address. But if you connect both table together and merge both table together, it defines the need denormalization format, where we will have single table like employee department with the attributes like employee number, employee name, job, salary, department number, and department name. So this is all about the dimension. The next terminology, work with your schemas or data warehouse, is measure. It's a term that actually rely on the dimension and always talk about the calculative data like the amounts, the cell number, the quantity, and the total number of cell, the yearly wise cell, etc. So these two terminology is actually helpful to identify the three different category of schema. We will discuss about the schema in the next video. Thank you.